Hi everybody. So this time we will be working on our next lesson, and that is going to be about direct variation. And so our goal is to be able to write an equation of a direct variation. So what is a direct variation? That's the first question, as usual. So a direct variation is a relationship that can be represented by a function that will always be in the form y is equal to k times x, wherein k is never equal to 0. K could be any number. So you will notice that whenever you have an expression that has y equals a number multiplied by x, that is a direct variation. And k, as you can see, that's a constant of variation. So it's the coefficient of x, and for us to be able to solve for k, it is simply the quotient between y and x. Okay, so you would see y is equal to kx. K is simply you divide this by x, divide by x, and you will see it's going to be y over x. Okay, so does the equation represent a direct variation? If so, what is the constant of variation? So you can see here, we have 7y is equal to 2x. Now remember, when we have a direct variation, what should be the format? It should always be following the format that says y is equal to a certain number multiplied by x. Is our y by itself in this equation? Well, it's not yet by itself. So can we make y alone? Definitely. So you have 7 times y. So for us to get rid of that 7, we have to divide by 7. So that's gone now. We also have to divide by 7. So what is this expression equal to now? So getting rid of all those 7, this will now change to become y is equal to 2 over 7 times x. So does it follow the pattern? Does it follow the form of our direct variation? You have y is equal to a number. And what number are we pertaining to? It's the 2 over 7, right? So a number, which is our k, and then the variable x. So since this has the same organizations, the same pattern as the direct variation, then we can say that this is a direct variation. So since we know that this is a direct variation, the value of our constant, which is k, is simply the coefficient of x. And what number goes with x here? It's 2 over 7. Okay, so that is the constant of variation. Okay, so let's have the next example. 3y plus 4x equals 8. So why don't you try this one and see if it is a direct variation or not? And if yes, you need to find the constant of variation. So try this one out. Go ahead. All right, so as you can see, our expression here is 3y plus 4x equals 8. So first thing, we need to make sure that we isolate y, since the direct variation format function it has y by itself. Okay, so to isolate our y, we have to subtract 4x on both sides. So we will be getting 3y is equal to negative 4x plus 8. And again, y is attached to a positive 3 here, so we divide by 3 everywhere. So our equation now is down to y is equal to negative 4 over 3x plus 8 over 3. So the question now is, does it look like it follows the pattern of a direct variation formula? So we have our y, we have equals to, we have a k. Okay, our value that is attached to our x, our coefficient, is negative 4 over 3. And then we have our x. But that's the direct variation. As you can see, there is that extra part on this function. And so this, because of this expression, this is not a direct variation. Okay, so I'm using just dv as a shortcut here. All right, so just remember, direct variation, easy to remember. It's just always in the form y is equal to a certain number times x. All right, so let's have our, oops, sorry, Let's have our next example. Okay, so does 4x plus 7y equal 0 represent a direct variation? Again, check if it is going to be following the y equals kx format, and then identify what the k or our constant of variation mean. Okay, go ahead, try this one out. All right, so your answer should pretty much look like this. It is a direct variation, and a constant of variation will end up to be negative 4 over 7, okay? All right, so now this time, we will not be given an equation, but instead we will be writing a direct variation equation, okay? So, suppose y varies directly with x, okay? So that is already established. So what do we know? We know that we have something that is y is equal to kx, because this is a direct variation based on this, okay? And y is 35 when x is 5, all right? So if y is 35 and then x is 5, then we know that we have a constant of variation, okay? From this part, can we identify what the value of k will be? Well, just imagine k is our variable, and we need to have it solved by itself, so it has to be itself. So we divide by 5, and so our k is going to be a 7, all right? That's our constant of variation. So what is the actual expression? So since we know that we have y varies directly with x, this k over here is simply going to be written as y is equal to 7x. This is the direct variation equation. Okay, so this is now our DV equation. That's the one that we are looking for. All right, are we done? Well, not yet. Why? Because there is a second part of the question, and in this part, it's asking us what will be the value of y when we change x to become 9. So remember, this is our equation, y is equal to 7x. It's asking now what is y. So 7 stays as it is, but this time we put in our x as 9. And as you can see, we have 7 times 9, therefore the y will be 63, okay? So when you are finding on whenever you are writing a direct variation equation, the first thing is, of course, from the, how do you call this? From the given scenario, it says there, y equals kx, it's the direct variation, okay? You will be given a value of y and a value of x so that you can find your k, all right? So always start with your k value. Once you have the k value, you can go back to the original, and this is where your equation would look like. And then because of this equation, you can now change the input value into different values of x, or it could be a different value of y. You have to solve for x. And from here, you can get the other missing variable, okay? So why don't you try this next example on your own? Pretty similar to what we just did earlier. Go ahead, try this one out. All right, so solving first for k, always solve first for k. You can use the value of y and x that are given, and you can see that our k will be -5, which brings us to our direct variation equation, which is y is equal to -5x. And because of this equation, we can now find a corresponding value of y once we put in a value of x, which is -15, and so our y is equal to 75. All right.